Ishani, can you hear me?
Yeah.
Okay, all right. So let's continue our geometry. I think we last did area and perimeter. So let's continue. The next thing up
Yeah.
is the triangle inequality theorem, which tells us a bit about the maximum and the minimum lengths which sides of a triangle can take. Yeah. So this is a very important rule which says that any side of a triangle must be bigger than the difference of the other two sides, which means side 1 should be greater than side 2 minus side 3 and shorter than the other two sides added together. So it should be less than the addition of the other two sides. So this places bounds on any side of a triangle with respect to the other two sides. For instance, in triangle ABC, if AB is 6 and BC is 11, what could be the length of AC? So can I say AC will be at least greater than the difference, which is 5, and will be less than the sum, which is 17, of the other two sides. All good?
Yeah.
Okay. All right. First question for this section. In the figure shown, which of the following could be the length of YZ? And we need to mark all these boxes which fit into the appropriate lengths for YZ. So can I say YZ should be equal to or greater than the difference, which is 5 minus 3, and should be less than 3 plus 5.
Yeah.
This is how it looks, which means it's more than 2 but less than 8.
Yeah.
And these two are the options, 3 and 5. Possible lengths of YZ.
Yeah.
Okay. Let's see. Next one. Length of a side of a triangle is 12 and the other side is 18. Which of the following could be the perimeter of the triangle? Let the third side be x. So can I say we have a range of values for x? X should be greater than the difference and less than the sum. Which means x is less than 30 but greater than 6. So indicate all the perimeters. So perimeter is the sum of all the sides. Can I say the sum of the other two sides is 30? So 60 should be greater than x plus 12 plus 18 should be greater than 36. You're basically adding 30 to all the sides here of this inequality. This, of course, is the perimeter of the triangle. So can I say perimeter should be between 36 and 60?
Yeah.
And two of these choices will fit the criteria.
Yeah.
Okay. Fantastic. Easy, right? So set up the
Yeah.
inequality. Side should be greater than the difference, but less than the sum. That's it.
Mhm.
Okay. So can you solve this and let me know what should be the answer?
Yeah. A, 9.
So can I say x should be greater than 17 minus 8 and less than 17 plus 8? This is 25 and this is 9. So x should be greater than 9. So this
Yeah.
cannot be the third side. Yeah.
Yeah.
Sounds good. Okay, next section is Pythagoras theorem, which involves a right angle triangle. So here we have two legs of the triangle, which are basically legs of a right angle, leg 1, leg 2, each of lengths A and B. And the largest side of this triangle, which is opposite to the 90-degree, is called as the hypotenuse. So Pythagoras theorem says that if angle C is 90 degrees, which is this, then the sum of squares of the legs should be equal to the hypotenuse. So these numbers ABC or these lengths ABC are called as Pythagorean triplets. An example is this. So there's a triangle, right angle triangle. One side is 3, the other is 4. The question is,
Mhm.
what is the hypotenuse? So can I say applying the Pythagoras theorem is 3 square plus 4 square should be equal to x square. This is 9, this is 16. So x square equal to 25. And hence x should be equal to 5. It can't be negative, so x should be equal to 5. Which means 3, 4, 5 are basically called as a Pythagorean triplet. These are
Yeah.
basically sides of a right angle triangle. Similarly, if the two sides are 5 and 12, that make it 25 plus 144 equal to 169. When we take a root of 169, it is equal to 13. So the
Mhm.
hypotenuse is 13, and hence the triplet becomes 5, 12, 13.
Yeah.
It's useful to know these triplets because then you immediately understand that it's a right angle triangle.
Mhm.
So it's possible that they could give you 3 sides and you will have to guess whether it's a right angle triangle in a question.
Yeah.
And that fact you can use to further solve the problem, of course.
Mhm.
It's good to know such triplets.
Yeah.
Also, one more thing which I would like to mention here is that if we know that 3, 4, and 5 is a triplet, then any triangle in the ratio of 3k is to 4k is to 5k will also be a triplet. Which means when k equal to 2, this triplet will become 6, 8, 10. When k equal to 3, this triplet will become 9, 12, 15.
Yeah.
When k is 4, and so on and so forth, it
Mhm.
becomes 12, 16, 20. Similarly, we looked at the other triplet, which is 5, 12, 13. So they are in the ratio of 5k is to 12k is to 13k.
Yeah.
That's a triplet. And hence, all the other multiples of k also become relevant triplets. When k equal to 2, it becomes 10 is to 24 is to 26. This is another example for triplet. And so on and so forth. Yeah, so there are many such triplets
Yeah.
because of this multiple ratios.
Mm-hmm.
Okay. All right. Let's solve this one. What is the area of triangle ABC in square centimeter? So one of the sides is 18, the other side is x. These two are the legs of the right angle triangle, and the hypotenuse is 30. So we've been asked what is the area of triangle ABC. So can we say area of triangle ABC is half base into height, which is half x into 18. And we don't know what x is. But we know that by Pythagoras theorem, 18 square plus x square should be equal to 30 square. So x square is equal to 30 square minus 18 square. One of the ways of solving this without calculator is this is a square minus b square, which is a plus b, a minus b. So I can write this as 30 plus 18, 30 minus 18, which is 48 into 12. And we know 48 is 12 into 4. So can I say x square is equal to 12 square into 2 square? So x is equal to 12 into 2, which is 24. Plugging it back here in the area, this becomes 24 into 18. 216. Yes? Any clarification?
I have a question.
Yeah.
I'm not sure if this is possible, but would a simpler way be to use the triplet theorem to guess that x is a multiple of the 3, 4, 5 triangle?
Yeah, you can do that. If so, can I say 18 is 6 into 3
Mm-hmm.
and 30 is 10 into 3. So it seems that 3 is the common multiple.
Mm-hmm.
And we know that 3, 4, 5 is the triplet.
Yeah.
So if I multiply by 3 everywhere, I get 9, 12, 15. And if I multiply by 2, I get 18, 24, 30. So 18 is there, 30 is there. So 24 is the answer. I could have also multiplied 3 is to 4 is to 5 by 6.
Yeah.
And that would have fetched me 18, 24, 30. So this is the other way of doing it, realizing
Mm.
that it's a ratio. So for that, we need to factorize 18 and
Yeah.
30. And the common factor will be the common multiple, k.
Mm-hmm.
Yeah. So good. You can also do this and try and guess.
One more question.
Yeah.
For 12 times 18, would you use a calculator for that or would you do it by hand?
Which one is that? 12 times?
It's 1/2 times 24 times 18.
This one? Yeah, you should use the calculator here.
Okay.
Yeah. Because if it takes you more time with calculations manually, then
Yeah.
use the calci, that will be faster.
Mm-hmm.
So here you don't have to do 24 into 18 divided by 2. Don't type three numbers.
Yeah.
You know that it's 24 into 9 or 12 into 18. Yeah. So if I put the calci on, so this thing I will just do 12 into 18. So it's pretty quick, right?
Yeah.
So I would suggest that you should start practicing calci.
Mm-hmm.
Start practicing it, to use it quickly. Not the manual calculator, the
Yeah.
PC calculator. So that will increase your speed gradually, and for the test day, you'll be very fast. So it's possible that
Yeah.
start typing it faster, you could be, even faster than manual. Like
Yeah.
48 into 12 is 576 and square root is 24.
Yeah.
Okay.
Mm-hmm.
Next. All right, what's this? What is the value of x in the triangle shown? Okay, so it seems that there are two right angle triangles, clearly.
Mm-hmm.
So the first one is this. So can I say this looks like 3 into 2 and 4 into 2. So the
Yeah.
triplet looks like 3, 4, 5 multiplied by 2 each.
Yeah.
So 6, 8, 10 looks to be the triplet. So this is 10. Then another triplet is 5, 12, 13, which we have learned. If we multiply by 2, we get 10, 24, 26, which means x will be 26. So I've not even used Pythagoras theorem. I've just used the knowledge of multiples, which is why I've
Mm-hmm.
taught you multiples.
Yeah.
Good, right?
Yeah.
It saves a lot of time. For instance, otherwise I would have had to do, suppose this is y, then y is root of 6 square plus 8 square. Look at how much time this takes.
Yeah.
Then this is 10, and then x is 24 square plus 10 square, and so on and so forth, right? Takes time.
Yeah. Mm-hmm.
So ratios, once you know, triplets, some basic triplets, ratios on that will help you solve problems faster. Some of them, not saying all of them, but many of them you'll be able to solve.
Yeah.
Okay. Next, hypotenuse of a right triangle with legs 7 and 24. So legs of the right triangle are 7 and 24. And this looks to be like a new triplet because
Mm-hmm.
7 has no factors, right? You
Yeah.
can't factorize 7. It's a prime. So it looks like a new thing. Nevertheless, can I say
Mm-hmm.
hypotenuse is root of 24 square plus 7 square?
Mm-hmm.
So this you can do it on the calci directly.
Yeah.
24 square plus 7 square is 625, and we know 25 square is 625. This is 25.
Yeah.
So you can make a note of this triplet as well in your list of triplets.
Mm-hmm.
Okay, so another triplet is 7, 24, 25.
Yeah.
So 14, 48, 50 will also be a triplet multiplied by 2. Yes?
Yeah.
Okay. So the answer here is C. Both the quantities are equal.
Mm-hmm.
Okay, next question. Isosceles triangle has sides R, 1.2 R. What is the area of the triangle? So let's draw this triangle. Can I say two sides are equal, isosceles, R,
Mm-hmm.
and the third side is 1.2 R. Now, always in a isosceles triangle, the perpendicular from the angle, which is the intersection of two equal sides, is also the perpendicular bisector, which
Yeah.
means it bisects the opposite side into two equal parts. So if the entire thing is 1.2 R, each of these will be 0.6.
Yeah.
So to find the area of the triangle, can I say area will be equal to half into h into base 1.2 R, which means we need to know h, the height. And
Mm-hmm.
since this is a right angle triangle, we can use Pythagoras. So can we say r square is equal to h square plus 0.6 r whole square. Also, we know 3, 4, 5 is a triplet. So 6, 8, 10 will be a triplet, which means 0.6, 0.8, and 1 also will be a triplet, by the way,
Yeah.
dividing by 10. And that's exactly what we have. We have 0.6 square, we have 1 square. So h clearly will be 0.8 r. So 3, 4, 5 is equivalent to 6, 8, 10 divided by 10 will be 0.6, 0.81. We have 1 here, we have 0.6 square here. So clearly h is 0.8 r without even calculating. And hence our area, plugging it back here, is half into 0.8 r into 1.2 r, which is basically 0.4 into 1.2, which is 0.48 r square.
Sorry, I have a question.
Yeah.
How did you get h equals to 0.8 R?
Okay, so 3, 4, 5 is a triplet,
Yeah.
and hence multiplied by 2 is 6, 8, 10 is also a triplet. And if I
Oh,
divide by 10, even that will be a triplet. So
yeah.
0.6, 0.8, and 1 is also a triplet. So if you see, we have 1 R, we have 0.6 R. So obviously H will be 0.8 R. Got it, right?
Mm-hmm.
Okay. So this was important. So just like we can multiply to get a new triplet, we can also divide to get another triplet.
Yeah.
So whenever you have decimals in Pythagoras theorem problems, you can divide triplets and get a new triplet, which is in decimals. So the clue here is 1 and 0.6. So when I multiply, I put a 0 in front, or multiply by 10, it becomes 10 and 6. So obviously h will be 8. But
Yeah.
everything is divided by 10. So h is not 8, it is 0.8.
Yeah.
Okay. And then we find area.
Mm-hmm.
Good so far?
Yeah.
Okay, next is a topic on 45, 90, which is a right angled isosceles triangle and 30, 60, 90 triangles. So let's see. So basically, when you have a square and when you draw a diagonal across the square, it divides the square into two equal parts. And obviously, the square, one of the angles is 90 degrees, and the other angles become 45 each.
Mm-hmm.
And hence, if you look at this triangle, it is a 45, 45, 90 triangle. I think we did this, that I'm not sure, but if we have a triangle like this where A, B, and C are the sides of the triangle, and small a is the angle opposite to side A, small
Yeah.
b is the angle opposite to side B, and small c is the angle opposite to side C, then we have sine A upon A equal to sine B upon B equal to sine C upon C. Which means that the largest angle of a triangle will have the opposite side to it as the largest side of that triangle.
Yeah.
Yes.
Yeah.
Now, in this right angle triangle of 45, 45, 90, clearly 45, 45, 90. And if I take these two sides as x each, can I say hypotenuse will be what? Root of x square plus x square,
Mm-hmm.
which will be root of 2x. And hence, the ratio of the sides will be x is to x is to root 2x. And these are the sides opposite to 45, 45, and 90 degrees in an isosceles right angle triangle.
Yeah.
Yeah. Okay. On the other hand, an equilateral triangle, can I say each uh, angle is 60 degrees? Same angle size. So this is 60, this is 60, and this whole thing is also 60. But when I draw perpendicular bisector from that 60 degree, it basically bisects that angle into two equal parts, 30 and 30 each. So
Yeah.
if I look at the left side or the right side of a equilateral triangle, it looks like this. So one angle at 60, another is a right triangle, and the third one is 30 degrees.
Yeah.
Okay.
Mm-hmm.
Now let x be the side opposite to 30. and let the other two sides we need to find out, correct?
Yeah.
Now, hypotenuse. So there are some important results. Sine theta, trigonometry, a bit of trigonometry here. Sine theta is equal to opposite side divided by hypotenuse, which means in this case, sine 30 degrees will be equal to x divided by h,
Yeah.
and sine 60 degrees will be y divided by h. Basically, always take the opposite side to that angle. Divide by hypotenuse. So that is your sine.
Yeah.
Sine 60 is half, and sine 30 is half, and sine 60 is root 3 by 2.
Mm.
So we can get h. H is equal to 2x. And we can get y from here. So y is equal to root 3 by 2 into h. But h is 2x. So we get y is equal to root 3x. So which is why the side opposite to 30 is x, which is this. Side opposite to 60 is y, which is root 3x. And side opposite to 90 is the hypotenuse, which is 2x. So this is how we arrive at these ratios. So I've given you the logic behind that. So I never remember this. If you want, you can remember. All I do is remember this. Sine theta is opposite to hypotenuse. Sine 30 is half. Sine 60 is root 3 by 2. And also a bit of trigo here, because it could be asked.
Yeah.
So theta is the angle. So let's take 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. So sine theta is all that you need to remember. Sine theta, sine 0 is 0, and sine 90 is 1. Everything else is in between. Sine 30 is half, sine 45 is 1 by root 2, and sine 60 is root 3 by 2.
Yeah.
And cos theta is nothing but, so I'll write here, cos theta is equal to sine 90 minus theta, which means cos 0 is sine 90 and cos 90 is sine 0, which means just the opposite. Just flip the order. So cos 0 is 1, cos 30 degrees is root 3 by 2, 45 degrees is the same, 60 degrees, cos 60 degrees is half, and cos 90 is 0. Just reversing this order.
Yeah.
And tan theta is the ratio of sine and cos. And it's just the ratio. So 0 by 1 is 0. This ratio is 1 by root 3. This ratio is 1. Tan 60 degrees is root 3. And tan 90 degrees is not defined. 1 by 0. So this is good to know, table.
Yeah.
You might not be tested on this, but since the coverage includes 30, 60, 90 triangles, it's important to know what is sine 30, sine 60, and cos 30 and cos 60.
Yeah.
Also, in problems involving slopes, slope of an equation is tan theta, by the way.
Yeah.
It's possible that tan theta could also be useful for slopes
Mm-hmm.
calculation. Yeah. So a bit of trigo basics in terms of, so this is how it looks. So I never try to remember all this. This 45, 45, 90 is easy because can I say 45, 45 will be the same xx and
Yeah.
90 will be definitely higher as compared to x.
Mm-hmm.
So it should be x root 2.
Yeah.
Yeah, and I just remember the basics. Sine theta is opposite by hypotenuse. Sine 30 and sine 60 is what we should remember. That's it. So let's solve a few problems. Let's do this. Perimeter of a square is 48. And what is the length of its diagonal? So perimeter is 48, right? So can I write 48 by 4 is the side, which is 12 each.
Yeah.
And they're asking what is the length of the diagonal. Can I say this is a right angle triangle with 45, 45 degrees? It's a square. So I can use the Pythagoras theorem
Mm-hmm.
and I can get root of 12 square plus 12 square, which is 12 root 2. This is one way. The other way is that 45, 45, 90 is in the ratio of x, x and root 2x. Now x is 12, so 90 will be 12 root 2. So that's your answer. So side opposite to 90 degrees is the diagonal.
Yeah.
Got it, right?
Mm-hmm.
Also, if you carefully observe this, okay, I'll write it here. Now we have derived this rule for 30, 60, 90, right? And we've
Yeah.
said that these are the angles and the sides are in the ratio x is to 2x is to root 3x. Now, root 3 is 1.7. So obviously the side which has the largest angle opposite to the largest angle will be the highest, which is 2. Side opposite to 60 degrees will be root 3. Side
Mm-hmm.
opposite to 30 degrees will be the lowest, which is 1x.
Yeah.
So 1 is to 1.7 is to 2 is the ratio,
Yeah.
approximately. For a 30, 60, 90 triangle.
Yeah.
Yes. Okay. A is x and B is 5 root 2 and they're asking what is x? So can we apply the so one way is we can apply Pythagoras, right?
Mm-hmm.
This will be root of hypotenuse, which is 10 square minus 5 square. This is root of 75, which is 5 root 5.
Yeah.
5 root 3 actually.
Mm-hmm.
This is one way. Second way is to realize that 5 and 10, 5 is half of 10. And if we remember 30, 60, 90, we remember sine 30 degrees is equal to half, which
Mm-hmm.
is opposite side divided by hypotenuse. Here opposite side is 5, hypotenuse is 10, which means
Yeah.
this angle is 30 degrees, which means the angle opposite, the side opposite is 5 by 10 is half, which is sine 30, which means this angle will be 60 degrees. So now we know the rule 30, 60, 90
Yeah.
is, can I say x root 3x and 2x? So x is given as 5, 2x we know is 10, and 60 degrees is what? Root 3 into x, which is 5. So answer is 5 root 3 is the side opposite to 60 degrees, which is x. Same as we got using Pythagoras theorem.
Yeah.
So two ways of doing it, whatever is convenient to you.
Mm-hmm.
Best is to just apply hypotenuse formula and apply Pythagoras. You don't have to get into thinking whether it's 30, 60. It might not always be the case.
Mm-hmm.
So if you want to be very quick, then just use Pythagoras theorem and get done with it.
Yeah.
See, on the real exam, we will not have time to think through fancy things.
Mm-hmm.
So we need to stick to our basics and do the basics fast.
Yeah.
Yeah. Unless you're very quick in identifying, okay, 5, 10, so this is 30, this is 60, so this will be, 5 root 3, then it's a different thing. Otherwise,
Mm-hmm.
just stick to Pythagoras theorem and just do
Yeah.
it quickly. Okay. Next, can you solve this? Quant
Mm-hmm.
comparison. In fact, I would need to show you this probably. Area of a triangle with sides 6, 8, 10. Can I say my triplet is 3 is to 4 is to 5 multiplied by 2 will become
Mm-hmm.
8, 10. So since this is a Pythagoras triplet, can I say it's a right angle triangle with the legs as 6 and 8 and the highest side as the hypotenuse, which is 10.
Yeah.
So area of a triangle will be half into base into height, which is 24. So that's
Yeah.
quantity A, and for quantity B, area of an equilateral triangle. So there's a shortcut formula. Area of an equilateral triangle is root 3 by 4 into side square. So if you know the side, you should be able to get the area of an equilateral triangle.
Mm-hmm.
So here the side is 8. It's root 3 by 4 into 8 into 8.
Yeah.
It's 16 root 3. And root 3 is 1.7 something. And 16 square we know is 256. So this will be
Mm-hmm.
greater than 25. And hence answer is B is greater than A. So again, I'm not calculating 16 into 7, 1.7. I know 16 into 16 is 256, 16 square. So 16 into
Yeah.
1.6 is 25.6. So my answer will be greater than 24. So hence B is higher as compared to A. So please remember this equilateral triangle formula, very important. Have I shown you this? How did we get this?
Which one?
equilateral triangle? No, right?
Yeah. I think you did.
Last time, did I show you? How did we get this formula?
You didn't show me why we got it. You just told me the equation.
Let's see why, since now we know it's 30, 60, 90 triangle. Suppose this is the equilateral triangle. When I say each side is, say, x, if I draw a perpendicular height, can I say that will bisect the opposite side into x by 2, x by 2?
Yeah.
So what is h? Can I say I can use Pythagoras theorem on this triangle? And that will be x square is equal to x by 2 whole square plus h square. And hence h square will be equal to 3 by 4 x square. Hence h is root 3 by 2 into x. We use this in area of triangle, which is half base into height. Base is x, so half x into height is root 3 by 2 x. So the answer is root 3 by 4 x square. Area of equilateral triangle. So just follows from basic geometry.
Mm-hmm.
So you don't need to know the height to find the area of an equilateral triangle. If you know the side, you can directly find the area. Root 3 by 4 into x square.
Mm-hmm.
Yeah. So this is fast and quick. Yeah. Good.
Yeah. Yeah.
Next. Okay. Now this is a very tough question. This is like hard variety. Jessica and Earl are creating decorations for a party by cutting triangles out of 8.5 inches by 11-inch sheets of construction paper. So clearly, the construction paper is a rectangle
Mm-hmm.
with 8.5 and 11 as the sides. Now Jessica is cutting out equilateral triangle. So Jessica is for equilateral, and Earl is doing 45, 45, 90, which means right angled isosceles triangle. Now, every triangle created will use full length of the paper, at least one side of each piece of paper. And both are trying to create largest possible triangles that can be done in this space. So it means will try to create an equilateral from here, and on another sheet of paper, Earl will try to create an isosceles right angle triangle. Yeah.
Mm-hmm.
Now, whose area is greater and by how much? Earl is making versus Jessica. So by how much is the area more? For the two largest triangles which would fit respectively into each of their sheets. So any clue how can we do this?
Mm, not really.
Always. So can I say there are two choices, okay, to create a triangle out of a rectangle. Either
Yeah.
take the base as the short side or
Yeah.
take the base as the long side. But a lot of times, if you take the base as a long side, your triangle can just move out of the sheet, which is not possible, right?
Mhm. Yeah.
It has to fit within. You need to cut it within. So as far as this 45, 45, 90, it should optimally utilize the space inside. So can I say
Mhm.
that when I look at this triangle, there are two ways of creating that 45, 45. One is using the short side,
Yeah.
and it will look like this. Can I see most of the paper is unused? But the
Yeah.
other way of doing that is by taking this, the larger side as your hypotenuse and creating a 45, 45 angle.
Mhm.
So your less space is unused. So we will go for this option. Now the question is, what is the area of this triangle? Yeah.
Yeah.
So now we come to 45, 45, 90 one first.
Mhm.
Let's say this is the rectangle. And we are taking a right angle. Now we don't know whether it meets or not. It really depends on the dimensions. But one thing is for sure, this
Yeah.
hypotenuse is 11, right?
Yeah.
And this will be a 45, 45 degree because it's given. It's a 45, 45, 90 isosceles triangle,
Mhm.
right angle. We know the
Yeah.
hypotenuse is 8.5, which means can we find what is the individual side? So that will be 11 by root 2.
Yeah.
Why is that? Because you know, x is to x is to x root 2 is are these ratio of the sides for 45, 45, 90,
Yeah.
which means x by root 2 is to x by root 2 is to x is the ratio. So we know x
Mhm.
is 11, and hence the other two sides will be 11 by root 2 each.
Yeah.
Also, you can use the Pythagoras theorem. So you can write x square plus x square is equal to 11 square. So
Mhm.
2x square is equal to 11 square. So x is equal to 11 by root 2.
Yeah.
Whatever is convenient. Yeah.
Yeah.
So what is the area of this triangle? Half into base into height. And both base and height are the same.
Mhm.
So the legs L1 and L2. So half into 11 by root 2 into 11 by root 2.
Yeah.
It's 121 by 4.
Yeah.
So I think it's 30.25. So that's the area of the isosceles triangle. Maximum which can be fitted. Got it?
Yeah. Yeah.
So can I also say that this makes logical sense because if the hypotenuse, okay, why did we choose 11? Because if the hypotenuse is lower, can I
Mhm.
say the side is also lower? Because side is nothing but hypotenuse by root 2. And hence, if hypotenuse is lower, side is lower, that means area is also lower. And hence, to maximize the area, we take the maximum or the largest hypotenuse, which is 11 instead of 8.5, which is why we have taken 11 as the hypotenuse here. Got it?
Yeah.
Okay, so this is the first part, by the way, very lengthy.
Mm-hmm.
If you get such problem, mark it for review and do it towards the end.
Mm-hmm.
Don't waste too much time. Each question is of the same weightage, by the way, on the exam. So you
Yeah.
won't get more marks to solve a very difficult problem.
I have a question actually for that, for the previous part.
Yeah.
What would happen if the triangle would not fit inside the, like if it would be greater than the 8.5, if the height would be greater?
That's a good question, which means you're basically asking if we can verify if this is fitting inside or not.
Yeah.
Correct? Which basically means you need to find the height, and the height
Mm-hmm.
should be less than 8.5, which means it will fit. Correct?
So you have to do all these calculations first before
Huh?
knowing if it works. So you have to do all the calculations to calculate the height before
Yeah.
knowing.
Yeah. So how do we find the height? We know the area is 30.25.
Mm-hmm.
So can I say that is also equal to, and this is additional, this is just for validation.
Yeah.
So can I say this is also equal to half into h into 11?
Yeah.
Yeah. So what is h? Can I say it is 30.25 divided by 5.5? Around 6. So can I say it is less than 8.5? So no problem. It
Yeah.
fits. So it's less than 8.5, so fits. So what we are doing is proper.
Mm-hmm.
Good question. You need to validate whether that right angle triangle, that point, that vertex is it within or is it outside?
Yeah.
So here it is outside. Had the length or the breadth been 5, then it would have gone
Mm-hmm.
outside.
Yeah.
But it's 8.5, so no problem.
Mm-hmm.
Okay.
If it would have gone outside, then what would be the next step? Like, what would you calculate next?
Then you can't make the triangle out of the larger hypotenuse. Then you have to
Yeah.
stick to smaller hypotenuse.
Mm-hmm.
So suppose if this were to go out, then you can't make it
Yeah.
here.
Yeah.
Then the only way you can make it is like this.
Mm-hmm.
Yeah. So we will then
Okay.
use hypotenuse as smaller side.
Yeah.
Yeah. Now we have second part, which is equilateral triangle. So let's draw the rectangle again. Let's say 8.5 and 11. Yeah. Now, if I take 11 as the side, how will the equilateral triangle look like? Will it go outside or inside?
Outside,
And why?
because every side would be 11, and
But that
then
does not guarantee whether it's
oh yeah.
inside or outside.
Yeah.
Is it inside? Is it outside? Which means we need to work with the height, correct?
Mhm. Yeah.
Now we know that this triangle is a 30, 60, 90 triangle, right? Equilateral triangle.
Yeah.
Okay. And we know that we are doing this on a larger base of 11. So can I say the side is 11 by 2? It will bisect. This H will bisect the 11 into two equal parts, 11 by 2. So 11 by 2 is opposite to 30 degrees. So can I write 11 by 2 here? And if you remember, the ratio is 1 is to root 3 is to 2.
Yeah.
So if I have 11 by 2, what is H? Can I say it is opposite to 60 degrees?
Mm-hmm.
So H will be nothing but 11 by 2 into root 3.
Yeah.
And that is 5.5 into 1.7 approximately.
Yeah.
And how much is that? Can we calculate? Five point five into 1 point. Yeah, 9.5.
Yeah.
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 So can I say 9.5 is greater than 8.5? So it does
Mm-hmm.
not fit, which means this vertex is actually this. It's not fitting.
Mm-hmm.
So not fitting, which means we can't construct the equilateral triangle on side 11 of the
Yeah.
rectangle. So we need to use what? 8.5. So now we construct it on 8.5. No problem.
Yeah.
So how to find the area of this triangle? We need the height. That's all.
Mm-hmm.
Can I say height is opposite to which angle? 60 degrees. It's a equilateral triangle.
Yeah.
It's opposite to this. And can I say the angle opposite to the base is 30 degrees. And
Yeah.
base total is 8.5, but base of this right angle triangle will be 8.5 by 2,
Mm-hmm.
which is 4.25. So now we will use same 30, 60,
Yeah.
90 concept. So it is in the proportion x is to root 3x is to 2x. Now we
Mm-hmm.
know side opposite to 30 degrees is 4.25. So side opposite to 60 degrees will be what? Root 3 into 4.25.
Yeah.
And hence area of the equilateral. So this is one way. Then area will be equal to half into base into height.
Yeah.
Half into base into height. Yeah. This is one way. The other way is directly using the area of an equilateral triangle formula. Root
Mm-hmm.
3 by 4 into side square. You know side is 8.5. So I think that is better. Root 3 by 4 into 8.5 square.
Yeah.
So that is equal to root 3 into 8.5. Can you just cross-verify the answer?
Yeah. Um,
Yeah?
yeah, I got the same.
Okay. Yeah, so 30.25 and 31.25.
I got 31.29. Does that make a difference?
Not much.
Okay.
It's fine. Second decimal is fine.
Mm-hmm.
So now we know which is greater. Equilateral triangle is greater.
Yeah.
Yeah, so that was the question.
Yeah.
Hmm. Okay.
Yeah.
All right. Okay. So one more question. All right. So now area of a parallelogram. Next topic, last topic. So
Yeah.
parallelogram looks like this, where the two sides, opposite sides are parallel to each other, and they are not at 90 degrees. Any two adjacent sides. So hence slanted. Also, this side is equal to this side, and the opposite sides are equal to each other in a parallelogram.
Yeah.
So if B is the base and H is the height, area of a parallelogram is base into height, not half into base into height. That is triangle.
Mm-hmm.
So here it is double, because if I draw the parallelogram, it is triangle A and triangle B. Both their areas are equal,
Yeah.
and hence area of this parallelogram is twice area of A, which is 2 into half into base into height, which is base into height, which is how you get this formula. Area of a rectangle, since it's 90 degrees, is length into width, and area of square is S square.
Yeah.
Yeah. So area of parallelogram also looks similar, base into height. Question. The figure shows three squares and a triangle. What is the area of square A? So what is the area of this? Now, if I factorize 9 and 12, see, can I say these are the legs of a right angle triangle? So clearly the Pythagoras should be used, or the triplet. 9 is to 12, can I write as 3 into 3 and 3 into 4?
Yeah.
We know that 3 is to 4 is to 5 is a triplet. If we multiply all three numbers by 3, we get 9 is to 12 is to 15, which means side A, side of square A is 15, which means area of square is 225.
Mm-hmm.
That's it.
Yeah.
Yeah. So no roots, no squares, nothing. Just direct ratios.
Could you go back to the previous slide for a minute?
Which one? Previous.
Yeah. Okay. Thanks.
Okay. What is the area of this rectangle? Can I say it's a rectangle, so this is a right angle triangle. Clearly we need x and area will be 15x.
Mm-hmm.
Now one way is your usual Pythagoras, hypotenuse square minus 15 square.
Yeah.
Yeah. So can I say this will be root of 10 into 40. So that is 20. So x is 20.
Yeah.
That's one way. The other way is the ratio method. 3 is to 4 is to 5. Multiply by 5 and we get 15 is to 20 is to 25. And this x is 20. So hence area of the rectangle is 15 into 20 is 300.
Yeah.
Yeah?
Mm-hmm.
Okay. Another question, quant comparison. Parallelogram ABCD is not a rectangle, which means this is not a right angle here.
Mm-hmm.
What is the area of the parallelogram? A and B is 50. So are these two equal? Which means they're asking what is the area of the parallelogram. Can I say it's always base into height?
Yeah.
So let's draw the height from there, over here. This is height.
Mm-hmm.
So how will we find height? There's no other data with us. To find height, I need this, right? This side. But I don't
Yeah.
know what is the length of this. Don't know.
Mm-hmm.
Where this perpendicular meets, I don't know what is x and what is 10 minus x. We don't know. Okay?
Yeah.
Which means it cannot be solved. But that doesn't mean that answer is D.
Mm-hmm.
Because if you carefully observe, height will be less than 5. Yes or no? Because 5 is the hypotenuse.
Mm-hmm.
Since 5 is the hypotenuse, the other side will always be less than 5 in that right angle triangle. And if I take area of parallelogram as base into height, we know base is 10. This whole thing is 10. And can I say I can write area should be less than base into height of 5 if we take it as 5, and
Yeah.
hence area should be less than 50 because
Mm-hmm.
B, which is 10 into h will be less than 5, will give you something less than 50. So 50 is greater than A, which means B is greater than A.
Yeah.